Hey, this is Mr. A, and in this lesson I'd like to talk about heating curves. But first, I need to talk about temperature and thermal energy. Because in a heating curve, it is a temperature versus energy graph. So let's make sure that we understand those terms before I move on to showing you a heating curve graph. Thermal energy, total thermal energy, is all of the kinetic energy in a substance plus all the potential energy. The kinetic energy, again, movement, is all the energy from the movement of the particles. It's really how fast the particles are moving. Potential energy is the energy stored in the intermolecular bonds, or what is keeping the particles together in the first place. Let's talk about the temperature. I think that's an easier thing to kind of get our head around. If I mention that it's how fast the particles are moving. Take, for example, two highly energetic gas particles. Now they're moving and they're bouncing around all over the place, but there's only two particles. There's not a lot of energy bound keeping them together, but yet their temperature is high because they're moving very quickly. Compare that to many liquid particles, as I've tried to show here. A lot more particles, there's a lot more energy in the bonds that are keeping them together. But liquid, as you know, is not free of those bonds. They're not moving all around vigorously. They're just really kind of sliding past each other. So it's a relatively lower temperature than the highly energetic gas particles, but more total energy simply based on the fact that there's more particles. And compare that to a small solid. Not as many particles as here in the liquid, so we have low energy and low temperature because they're solid. The particles aren't moving around very much. Let me try one more thing to try to help you to get your head around temperature and energy, and I think this works more for most students. Think about temperature as being the tempo of the dance music. We're at a dance, and there are lots of people around, but we want to talk about what's going on the dance floor. If the DJ puts on a song that's got a really fast beat and a couple of dancers go out there, yeah, those dancers, they're hot. They're really moving all around. But compared to all the people that are just sitting around going ho-hum, yeah, those are the two crazy guys that kind of go out there every time that they put on their fast music. Highly energetic, a lot of temperature out on the dance floor, but not a lot of energy. Now compare that to, I don't know, so when a slow song comes on, it's like, well, everybody can dance slow, right? So it's a popular slow song, so everybody grabs a partner and they go out onto the dance floor. Now, the movement is slow, but overall the energy is greater because there's more people out on the dance floor. In fact, if they're like doing a waltz or something like that, you can't help but if you're an instant bystander, not on the dance floor, but watching all these people, you kind of have to move too, right? Because there's so much energy out on the dance floor. I don't know if that helps you, but it really helps me when I compare what temperature is, which is how fast the particles are moving, compared to energy, which is just really a statement as to how many particles we're talking about.